Hello everyone. Today I'm going to cover just a rhombus and a rectangle. We'll do the square when we come back to class together. So today I just want to focus on the properties of a rhombus and a rectangle. To me, the rhombus is a slightly harder than the rectangle only because you're not as used to it. I think you've seen a rectangle and you're pretty good at it, so I plan on going much faster through the rectangle than the rhombus. The first thing, if you look at a rhombus, what most people call a rhombus is a diamond. And the first thing we say, what's so nice about a diamond is that the sides are all so pretty. All the sides are congruent. So all sides are congruent. But you can see a rhombus doesn't necessarily stand straight up and down like a square. It doesn't have to be as exaggerated as this, but the point is to show you this is a rhombus and not a square. What's unique about a rhombus really becomes the inside of the rhombus. So you see in this picture, I have the diagonals. And now we already know because a rhombus is a parallelogram that this and this and this and this would be the same, meaning diagonals are bisected. We already know that. That is because it's a parallelogram. What is new to a rhombus is that these diagonals are perpendicular, which what becomes important is that now I have 90 degrees in here, which now sets us up for 4 right triangles. So what's unique is that diagonals are perpendicular. Now, if you wanted to say they were perpendicular bisectors, you could, but the bisecting part comes from the fact that it is a parallelogram. So since in here, this is the same as this, and this is the same as this, if I take these out of here, or those are the same, these triangles, this triangle and this triangle, and this triangle and this triangle must be exactly the same by side angle side. Or if these are the same, then it's by hypotenuse leg, whatever you want to call it. But all 4 of these triangles, this, and this, end up being exactly the same, which is where our last property becomes. And this is what's different than a parallelogram. Not all parallelograms have these properties. So all the sides are the congruent, the diagonals are perpendicular, and the last part, which is kind of hard, is that these corners are going to be bisected by the diagonals. Why? Because our triangles are the same. So if this is 30 and this is 60, then this is 60 and this is 30 and this is 60. So it is opposite angles are bisected, or I should say diagonals bisect opposite angles. Okay? So it's kind of a hard property to memorize, but what I need you to know mathematically is that there's always going to be a right angle. So if this is 40, this has to be 50. If that's 50, then the same corner is bisected. So the diagonal bisects that corner. So if that's 50-50, alternate interior, because it's a parallelogram, this is 40, 40, 40, 40. So real quick, if you go to your rhombus on your flow chart, please fill that in. You can pause the video if you don't need me to write it, but it's all sides congruent. Diagonals are perpendicular. And then lastly, it's that the diagonals bisect opposite angles, okay? So now let's do a algebraic problem involving a rhombus and see that you need to know these properties in order to figure out the inside of a rhombus. Okay, so I'm going to go to this one. If you would, go ahead and see. Okay. Pause the video, see if you can. All right, something to think about. It's still a it is a rhombus, which means it's a parallelogram, which means that's 110. So if that is 110, it means this angle has to be 70. This angle has to be 70, which means this has to be bisected because it's a rhombus. X is 35 degrees. If you got that, great. Okay, and now here is the problems that we are going to face when it comes to rhombuses and all the parallelograms. So you're going to get math problems like this. What you're really going to do, I don't even look what they're asking for me. I see what they give me, and now I try to figure out every side or every angle involved. Now, since there's a right triangle, that is the first thing I'm going to think of in a rhombus, is that the diagonals are perpendicular, making this a right triangle. If I have right triangles, I need to bring back Pythagorean theorem, and I need to bring back trig. So what you're going to do, take a second, see if you can do it before me, and see if you can find all angles inside here, and given 7, can you find all the side lengths? Okay, I think the first thing I would do is that if that is 7, I know that this is 7 because it is bisected still because it's a parallelogram. Next is the angles. First, it's kind of obvious to me if that's 34 that I can find this angle by taking 90 minus 34 and getting 56. Now, couple things we could think about. It's a parallelogram. Alternate interior angles always happen, so I could put 56 on that side and 34 there. At that point, you might get stuck if you don't know the third property of a rhombus. Third property is the diagonals bisect the corners. So that's 34, that's 56, that's 56, that's 34. At this point, take a second and fill in what you can in the problem. So your WZV should be 34. And your XYZ should be 56 times 2, 112. And your WY should be very easy. That's 14. And XY, so this is where I'm stuck. I don't have any other side length inside. I don't have any other side length on the outside because all the outsides are the same. But what I can do is make a right triangle involving XY. So this is XY and V's in the middle. V is where it's 90. VY is 7. And I could put 56 at Y, and now I'm asking for X here. As long as I have one side length and an angle measure, I can use trig. Now, you could also put in 34 instead. It was up to you. So now please calculate. Are you going to use sine, cosine, or tangent? If you used 56, then it's the cosine of 56 is 7 over X. That is when I'll have to do X equals 7 divided by cosine of 56. And we want to make sure we're in the right mode if we have a new calculator. So it is 12.5. So this is a problem that you might have on your homework tonight. You can go back to these notes to check it. And we'll practice this together tomorrow.